everyone, welcome to Data Science Works, and today in the episode 2 I'm going to discuss about a very important topic, and this is one of the most important question, or the concept people ask in your ML interviews, that is your central limit theorem and the questions about your normal distributions. So let's get started. So I'm going to share my screen. This is today's topic, central limit theorem. So first I'm going to, before starting with the central limit theorem, let's discuss what is normal distribution. So normal distribution, you can see on the left hand side, this is a curve you can see. Okay, so most of the people already know, this is also known as the bell-shaped curve. So let's discuss about the normal distribution. So it's also known as the bell-shaped curve, so because it is, next is what's the characteristic of this distribution? So it's mean equal to median and equal to mode. So all the three, mean and median and mode, are equal. Next, it is symmetrical. So that's the characteristic about normal distribution. So now, I have started taking the interview questions along with the concepts as we move on. So this is the interview question. So explain 68, 95 and 99 rule in regard to the normal distribution. So any guesses? I can say, so in normal distribution, so if we see the curve, so I'm going to, show you also in the next coming slide. So approximately 60% of your data is 68%. So this term is saying 68. So 68% of the data is falling within one standard deviation of the mean. Next is approximately 95% of your data is falling within two standard deviations, and 99.7 to be precise of the data is falling within three standard deviations. So we have learned 68% within one standard deviation, 95 within two standard deviation, and 99 within three standard deviation of the mean. Now, you might be having down like what do we mean by standard deviation? And also standard deviation, as we all know, tells us how much your data is spread out or dispersed. So if your standard deviation is smaller, so can you say, how the graph will look like? So if the standard deviation is smaller, that means the data is not that much dispersed. And so we can say the graph will be narrower. Now, what happens when the standard deviation is large? So the data is more spread. So when the data is more spreaded, that means your graph will become, this larger. So let me explain you with this help of the graph, because it will be more clear. So yeah, so this is the graph I have covered. So this I was saying, so this is the mean. Mean is your central line that is denoted by your mu. Okay. And mu, I have talked in the previous episode, if you have, seen this, the population mean. Okay, the population mean is denoted by your mu. And sample mean is denoted by your x bar, something denotions. So now let me get back to this, and this is your mean. And now what this thing told us, approximately 68% is falling within one standard deviation. Okay, so let's see what do I mean by one standard deviation. So this is mean, and with one standard deviation on the right and one standard deviation on the left. Why? Because this shape, the normal distribution is symmetrical. Okay, so it is symmetrical about the mean. So as you can see, this is the mean. So mu plus sigma and mu minus sigma. Why I'm doing only one standard deviation? Okay, so if you now 68% of the data will be falling within this. Now let me get back to the right, mu plus 2 sigma. So two standard deviations. So two standard deviations to the right and two standard deviations to the left from the mean, that covers approximately 95% of your data. And next is three standard deviation from the mean, that is mu plus 3 sigma and mu minus 3 sigma. So because it is symmetrical, so we have to go right side also, mu plus sigma, mu plus 2 sigma, mu plus 3 sigma, and left also. Okay, mu plus sigma, mu minus sigma, mu plus 2 sigma, mu minus 2 sigma, mu plus 3 sigma and mu minus 3 sigma. So mu plus 3 sigma and mu minus 3 sigma is covering your 99% of your data. So this was about the 68, 95, 99 rule, and this is one of the most asked questions in that are inclined more towards statistical kind of thing. So they ask like, can you define 68, 95, and 99 rule in regard to, I mean, this normal distribution? So you can say these points. So that was about it. Now we understood what is normal distribution, its characteristics, like mean is equal to median is equals to mode. Okay, and it is also known as bell-shaped curve, and it is symmetrical, and we understood this rule. Now the concept comes for today is the central limit theorem. So central limit theorem, so let me define. So suppose we have a statistical population, and now you know what do I mean by a population, because I have already explained in the previous videos. So these all my coming videos will have some terms that are your basic terms that I have already explained in the introductory video. So you can see if you don't know that. So we have a statistical population. Population is basically a set of your, I mean, for summary, I'm saying it is a set of your events or your set of your, I mean, all your data points, right? So that has some distribution. So we have a population that has some distribution. So what kind of distribution? Distribution tells how your data is distributed. How your data is distributed, it can be uniform distribution, or it can be binomial or exponential, or it can be normal distribution. So we have a statistical population that has some statistical distribution, that has some distribution. Now, what if I take some large number of random samples? Okay, so suppose for an example, I have a uniform distribution. Okay, and from a uniform distribution, I am randomly taking a large number of random samples from this uniform distribution and then calculating the mean of these samples. Okay, so can you tell me, like, when I'm taking the samples from the distribution and then calculating the mean of these samples, what I'm calculating, it is a statistic, because statistic is with respect to your sample, and parameter is with respect to your population. So I have a population, I mean, okay, and that is distributed with regard to some distribution. Now I'm taking samples and calculating the mean of these samples. So what central limit theorem says to us is, when you draw, so if we select large number of random samples from the uniform distribution and then calculate the mean of these samples, then these means are going to be normally distributed. So you might be having doubt, okay, I have taken some random samples from the uniform distribution, but now it is saying like the mean of these samples are normally distributed. So that's what central limit theorem says. So even though we calculated the mean using the data that is itself uniformly distributed, but they themselves are normally distributed. So that's what about central limit theorem. So takeaway. So what's the takeaway from the central limit theorem is that regardless of your population distribution, it can be anything. It can be uniform, it can be binomial, exponential, or normal. It can be anything. If you take large number of random samples, if you're taking a large number of random samples and then calculate the mean of these samples, okay, then you're calculating the mean of these samples, then they're going to be normally distributed. So how you have taken, I mean, this large number of samples and then calculated the mean. Okay, when you're calculating the mean, you can simply plot the mean, right? So for example, this mean, so when you see and when you connect the dots, so the mean will be normally distributed. Normally distributed means we will see a bell-shaped curve, right? So interview question, let's get back, I mean, what question they asked. So what is the sample size? So I was saying again and again, so if you take large number of samples, again I was saying if you take large number of samples, so what is the size of these large number of samples? Anyone can ask you in the interview question, like what is the sample size for which the distribution of sampling means will approach towards a normal distribution irrespective of your population distribution. That means you have to apply central limit theorem here. And what's the sample size? Can you guess? I mean, what, at least like what large is large? I mean, is large 100 or it's 1000 or it's some number that is defined? So the answer is, this holds true for sample size is over 30. So 30 is the value. So this was, I mean, a good question. So keep track of it. Next is, this is the summary slide, what I have told. I mean, pardon me for my drawing skills, please. And this is just for the summary. This just shows what is showing. So this was a normal distribution. From normal this was a uniform distribution, and from this uniform distribution I've taken large number of samples and then calculated the means of these samples. They were normally distributed. Okay. And I've taken, this samples from this distribution, then also, so regardless of this or any population distribution you have, okay. So, but when you calculate, when you take large number of samples and repeat this over again and again, you will see the mean are going to be normally distributed. They approach towards a normal distribution when you connect the dots. So that's all about today. We discussed what's the normal distribution. We discussed some few, interview questions that was tricky, and the central limit theorem. So that's all. Thank you.